All right, last but not least here is doing some systems of equations. So let's just practice solving. Remember, you could graph it, you could use substitution, you could use elimination. In this case, it actually doesn't tell me what to do. So unless I have a variable that's already isolated, I'm just going to use elimination. So the main thing we want to do, remember, is get the coefficients to be exactly the same. So what we want to do is find the LCD. Now, typically, you can find the LCD for the X's or the Y's, but I usually like to find, you want one to be positive, one to be negative. Well, since here, these coefficients are already one's positive and already one's negative, I'm not going to choose that one though, because actually the LCD of 3 and 4 is 12. The LCD of here is 6. So I prefer to find the LCD of the smaller number. But since I want one to be positive, one to be negative, I'm going to make one of my scalars be negative, and I'll just make the top 2 to be a -2. And then I'll multiply by 3. So now I need to multiply everything times everything, because you have to produce what we call equivalent equations. All right. So now let's get a new system. So my new system now is a -6x plus, or that's actually not plus, that's going to be a -8y equals a -24. And then over here, I'm going to have a positive 6x minus a 9y equals a -27. Okay, now I have these up. Now I can just go ahead and add them vertically. And what's going to happen is I'm going to get rid of my x's. So therefore, this will be a -17y. This is going to equal a -51. No, sorry, that's, yeah, -51. So that'd be a -51. Divide by -17, divide by -17. Y is going to equal, looks like a +3. Now I just need to go ahead and solve for x. So remember, just plug it back into one of those equations. It doesn't matter which one you do it in. I'll just choose the bottom equation because I don't know. I'll choose the bottom equation. So therefore I have a 2x minus a 3 times 3 equals a -9, right? So that's a 2x minus 9 equals -9. And then I'll just add a 9 to both sides. 2x equals a 0. So therefore divide by 2, x is also going to equal 0. So now this one is already nicely kind of created for us, right? So for this one, to go from, all I need to do is multiply by 3 on one equation. But again, I want it to be one positive, one negative. So I'm going to make this a -3. All right. So when I do that, I get a -9x minus a 6y. And then therefore that's going to equal a -66. Then over here, I have a positive 9x. This is going to be minus 8y equals a -4. Okay. So now I have the same coefficients. One's negative, one's positive. I can add them up vertically. That's going to eliminate those. That's going to give me a -14y. And therefore, this is going to be a -70. Right? I'm assuming I didn't do anything correct. That's going to be -6y. That's going to be -66. Okay. I don't think that is going to be there, but so I guess we can use a fraction here. So I'll do a 70 divided by a 14. Oh, that equals 5. I guess I probably should have checked my work here. So I divide by -14 on both sides, and I get y equals 5. Okay. And again, just to go ahead and solve for x, in this case, I'll go ahead and plug it into the top equation. So I'll do a 3x plus a 2 times 5 equals 22. So 3x plus, let's see, that's going to be a 10 equals 22. And then subtract 10, divide by 3. I'll just do my work. I always like showing my work. I don't like doing mental math, because when I'm doing mental math, what happens? I make mistakes, or then students always ask a question like, hey, where'd this number come from? Or how do you do this? So x equals 4. All right. Now, last but not least, I just want to cover inequalities. And graphing inequalities, remember, we need to worry about this like with the shading, the test points and where everything's going to be at. So in this first example, basically what we want to do is basically just kind of rewrite these as in our slope-intercept form. So I'm just going to do a 3x plus 5y is less than or equal to a 3. And then I'll do a 4y plus x is greater than or equal to an 8. Okay, so by putting this into slope-intercept form, I'm going to subtract a 3x on both sides. So I get a 5y is less than or equal to a -3x, -3x plus 3. Okay, then I'm going to divide by 5 on both sides. So y is less than or equal to a -3/5 x, and then plus a 3/5, which is going to be like, close to like 0.5, right? Or that's roughly 0.6. That's equal to an 8. Okay, so then over here, I'm going to kind of do the exact same thing, just subtract the x. Then I have a 4y is going to be greater or equal to a -x plus 8. Divide by 4, divide by 4. Y is greater than or equal to a -1/4 x plus 2. Okay, all right, so now let's go ahead and graph this. And again, the graph, I'm not shooting for perfect here, ladies and gentlemen. I am just trying to get an idea of what this graph is going to look like. So 3/5 is going to be like some, let's say 1, 2, 3. I can just do 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And actually what I'm going to do is I'm going to copy this because we have one more problem to do. So I want to use it again. All right. So let's go ahead and graph this. So 3/5 is going to be like roughly somewhere there. And then I'm going to go down 3 to the right 5. So down 1, 2, 3 to the right 5, 1, 2, 3, 4, 5. Cool. Okay. Now this is less than or equal to, so therefore it's going to be that line, this boundary line is going to be included. All right. And then what we need to do is just kind of use a test point. So let's choose 0, 0. Does that work? 0, right, is less than or equal to 0 plus 3/5. So 0 is less than or equal to 3/5. That is true. So therefore we can say this is all the points that are below the boundary line are going to be true. Now let's graph y is greater than or equal to -1/4 x plus 2. So we'll go up 2, 1, 2. And then now I'm going to go down 1 over 4. So 1, 2, 3, 4. So it looks like that. It's going to have a slope that's going to go like this. Okay, so it looks like we're going to have to extend this a little bit farther to kind of see. Okay, and then here, that's what my graph looks like there. And now what I want to do is use my test point. So this one says 0 is greater or equal to 2, right? When you plug 0 in there, and so my test point here is false. So therefore, that means everything up here is going to be true. So if you kind of see where do they intersect in this little region right there. So that's going to be the solution to the system. All right, let's just do this one more time, just to kind of get a good idea. So we have x plus a 2y is less than or equal to a -4. And then here I have a 3x minus a 2y is greater than a -4. Okay, so let's go ahead and solve for y. And then, so we can go and graph them. So subtract x. So 2y is less than or equal to a -x minus 4. Divide by 2, y is less than or equal to a -1/2 x minus 2. All right, and then over here, we're going to subtract a 3x. I'll have a -2y. It's going to be greater than a -3x minus 4. Divide by -2, divide by -2. So y, remember when we divide, though, we have to flip the sign, right? So that's going to be y is less than, not that way. Y is going to be a less than, let's see, this would be positive 3/2 x, and -4 divided by -2 is going to be a positive 2. All right, so let's go ahead and copy and paste that right there. Perfect. All right, let's see how this looks. So I have a -2, so I'm going to go down -2, and then down 1 over 2. So down 1 over 2. Okay, so my graph is going to look something like that. Just try to mimic the slope as best as possible, and that is less than or equal to, so therefore the boundary line is going to be included. This one, though, is less than, so this boundary line is not included. So I'm going to use dashed lines to represent this. So I'm going to go up to 2. That's my y-intercept. And then let's go up 3, so 1, 2, 3 over 2. Okay, so that is what this boundary line is going to look like. Not really sure if that's the right x-intercept. We're just trying to ballpark here. We're trying to find the region that they intersect. All right, so now let's use a test point. I'm going to use 0, 0, since they both don't go into 0, 0. So 0 is less than or equal to a -2, right? So if I plug 0 in for x and y, I get 0 is less than or equal to a -2. That's for this one. That is false. So therefore, it looks like all the points below the line are going to be true. And then here, 0 is less than 2. 0 is less than 2. That is true. So that means all of these lines are worked. So therefore, it looks like the boundary area or the solution is going to be from right there to right there.